Hello, so for my capstone project for Data 606, I'm going to be working with vehicle collision data, trying to understand it and use it to predict severity of collisions based on the surrounding data and use it to sort of uncover the determinants of the factors that go into severe crashes. So the problem in a nutshell is that car accidents in America are a huge, detriment to both human and financial health. Some figures here, they lead to approximately 33,000 deaths, 3 million injuries, and $871 billion in costs, which for comparison, the most recent U.S. defense budget was $686 billion. So you can see this is quite a massive, costly issue, and there's a lot of efforts going in to try to alleviate this and to make accidents less damaging and making America's cars and roadways safer places to be, but there's still a long way to go. So my contribution here, I'm sort of working on two different things. First, the data. It's a collection of about 3 million accident records going from February 2016 to I believe the end of 2019. These are accident reports coming from MapQuest that were sourced by several different APIs. These include basically very detailed times, geospatial data, the coordinates, the towns, cities, streets, some other accident severity data, and also weather details at the time of the accident. And also, I'm including basically a state-by-state report pulled together by 538 from a couple different sources that tries to quantify a couple metrics describing bad driving. Includes such things like average car insurance premiums, number of drivers involved in fatal accidents per state, and a few other statistics, mostly surrounding fatal accidents, which is what I'm focusing on mainly. So my first goal is to predict the severity of these accidents based on assembled data. In this data set, severity is measured, it's on a 1 to 4 scale, and it's measured by how large of a delay that the accident causes, essentially. So shortly after an accident happens, this is pretty easily determinable based on how big of a backup it is. But immediately, it's not always known how severe an accident is going to be and how much it's going to tie up the roadways. So being able to predict the severity based on information that would be immediately available from the first report of this accident, the time, location, weather data. So in practice, this could be embedded in a GPS system, and this would be able to immediately warn drivers who are on the road about how badly this accident would affect their commutes with a high degree of accuracy. So my second goal as well is to uncover the biggest factors that lead to these severe accidents, and the positive implications for this are very apparent. If it's found that certain areas, certain types of roads are dangerous, these can be improved. Vehicle safety features could be added. If there's an issue like there's no lighting in certain kinds of roads, infrastructure can be improved. There's just a lot of different ways for that to go depending on what is found. So some of my methodology I'm going to employ after cleaning the data, getting it to what I want it to be, very thorough. I'm going to do some very thorough exploratory data analysis, see how these features interact with each other, try to find some apparent trends. There's a whole lot of data, and the geospatial nature of it trends well towards the potential to visualize it. So there's a lot of things that can be found out in the early stages with working with this data. So again, with the geospatial nature of it, so for selected areas of interest, just because this would be wildly impractical to do across the entire nation, I'm looking to employ some spatial statistical methods for this data set, basically to investigate any clustering and dispersion patterns that accidents show. That can be determine the location and the significance of any hotspots I find. And for discovering the determinants, leading to, these big accidents, I'm going to employ some factor analysis methods, to find these out. And for the, accident severity prediction, it's, categorical data on a 1 to 4 scale. So I'm going to, experiment with several multi-classification algorithms to, try to predict severity, with an emphasis on being able to predict the most severe accidents, as these are the most costly and the most important to be able to, immediately warn commuters on the road.